All right, so it's 7, so I'll get started. Today we're going to be going over network security and active recon. These are pretty hard to cover in an hour because if you're like in a security job, you're going to be using this stuff like every single day. Like this is a whole field. It can take probably like 4 or 5 meetings worth of content, but I'm going to do my best to zip through the fundamentals and the practical stuff. And assuming we can get the infrastructure sorted out, you guys will be able to log in to our cyber range and then conduct like a full attack where you go through network recon and then host reconnaissance, and then hopefully a password attack, exploiting a vulnerability, and finally getting a web shell on that target. And I'll go through what all that means through the course of this meeting. So this is the meeting flag for today. You don't have to like rush to go grab it. You can download the slides from online. Okay. So we're gonna go over like a brief overview of like how networking works at a high level. We're not gonna get like super into the weeds, just enough to understand what your tools are doing. Then we're gonna get into active recon techniques. So that's gonna be port scanning, which is like the most common. We're gonna go for service-specific recon. So if you see, hey, they have a file share open, they have a web server, right? What can we do to go get more specific information from that? And then I'm going to briefly go over like a little bit of common edge cases you might encounter doing this that, you know, might be a bit of a head scratcher because it'll be like, hey, why doesn't it work? I just think I have to kind of just figure out from experience. And then I'll briefly go over some ways of gaining access. They're totally not exhaustive, but it'll be, you know, for a given service, right? Which if you remember from the blue team meeting, it's some functionality that's exposed. If it's misconfigured, can we leverage that to gain access to things we shouldn't have access to? Can we exploit a known vulnerability, right? Using some code from online, maybe tweak that, use that to get in, get some kind of, you know, way to read files or maybe run commands. And is there a way to exploit, you know, human mistakes? Can we figure out, you know, someone's password because it's weak and there's no rate limit? Or can we try an old password against a bunch of accounts? Or is it like a website where it'll return an error and be like, hey, this username doesn't exist. So I can figure out what usernames do exist, right? Or can we pull the email scheme from a company? All of these things are methods of gathering information that are going to be very, very useful for actually like gaining access to your targets. And then at the end, assuming the info is up, we'll have a live demo. And then once I demo it, you guys can go follow along and go run that attack. So infrastructure update. The reason things are not as functional as last time is because before we had the servers hosted in Henry's house, which was great for, you know, everyone in this room because it works. It was not great because he had like jet engine style fans in his living room. So, you know, we moved that up into this building. We have to deal with some quirks of Illinois Net and their firewall. So right now the cyber range is no longer accessible outside of Illinois Net. That's okay because your actual Pwny OS boxes are accessible. So you should still be able to log in. And then the domain has changed slightly. It's https pwnyos.purple.sigpwny.com 443. That's how you can go log into the boxes now. And we'll go, once it's like solidified and guaranteed working, we'll go pin this in the Discord so you guys can log in. So we'll access your Pwny OS anywhere on the cyber range, only while you're on Illinois Net.
It should work. I mean, you can try accessing that URL and boot up your own OS. If you have any internet issues, just let me know. I'll try my best. I'm tired.
Yep, yeah, the login just worked. I opened a new tab, so should be good to go. All right, so I'm going to briefly be going over like the most common stuff in network security. This is like a huge discipline. And I'm going to start with just a basic example of TCP/IP. Right, so it's got multiple layers of network, and like these are kind of pedantic, honestly. It won't matter a lot of the time because we are mostly looking at the transport layer, which is how we're sending stuff, and the application layer, which is the protocol we're talking and like the stuff we're actually sending. And the reason this is important is that understanding this is how we're going to be able to identify services, right, on targets. So an HTTP server is a service that can be served. It's a serve web content with the HTTP or HTTPS protocols by default on ports 80 or 443, right? Now, what network security is really about, right? There's a lot of different types of security that are focusing on different themes. Network security is really about the application security of your services, and then trust relationships that occur in networked environments. And sometimes these things will come together, sometimes they're separate. Today we're focusing on the security of services. When we get into Active Directory later on, that's going to really be deep in trust relationships. And there are going to be a lot of services that you're going to see commonly, especially in enterprise environments, right? There's HTTP servers, which is like your websites or APIs and such. There's SMB, a server message block. That's like when your Windows computer can go share files to other computers on your network. There's SSH, secure shell, which if you have a password or key, you can log in. There's network file systems. There's multiple families of SQL, which are like databases you can go log into and maybe manipulate. There's Windows remote management and many, many, many more, right? There's going to be a huge diversity of services. You can get familiar with all of them, but you're not going to be an expert in all of them. So it's important to just understand at a broad level how they work, how you can identify them, and then be able to quickly pivot into understanding things specific as you go on. So this is like the basic like internet networking. Can I just see a show of hands? How many folks here know what IP addresses, ports, and protocols are? Oh, thank goodness. You guys are going to give me a very easy time because I can just kind of skip through this. So yeah, basically the transport layer is how we do our end-to-end communications. TCP is going to guarantee the data gets sent through. It's a bit slower. UDP, you're just firing it off into the void. Those are how those two sort of differ. There's going to be 65,036, I think, ports, maybe 35 to 36, to run each of these different connections on. Right, so connect to an IP on a port, and then you'll talk with a protocol. And again, I think everyone here already knows this, so I'm just going to skip through it. But yeah, TCP is going to ensure reliability and speed, so you don't have to worry about a lot of things like checksums or whatever that's handled by the protocol. UDP, again, you just send it, and that's kind of it. So UDP is more for like where speed matters, maybe not the integrity of the data. TCP is kind of the standard. The overwhelming majority of services you see are going to be TCP. So hopefully you guys are all familiar with this, but if not, there's a question of how do a client and server actually like synchronize, right? When they're talking to one another at the transport layer. And this will happen through what's called the TCP three-way handshake. Where the client will be like, hey, I'd like to sync up with you. The server will be like, all right, like I've acknowledged that. We're going to go sync. And the client will finally be like, okay, we're good to go from this point on. That's a high-level overview of how that works. We can actually manipulate this sequence later on to be able to get information. So here's what happens when we're closed, right? When we're talking to a closed port, what was before is open, we're going to send our SYN, and then one of two things will happen. If it's not behind a firewall, it'll send an RST, a reset, be like, go away, right? Like, we're not open, go away. If we're in a firewall, it'll just drop it quietly, right? You'll get ghosted. That's the difference. That means that if you're trying to do a full connect scan against it with a firewall, it actually take quite a long time to just send it, wait, did we time out, right? And then, oh yeah, it's not open, move on to the next port. So now that we have like a brief, like super high speed overview of how networking and TCP works, right? These are some example services, and each of these expose functionality, and they're each going to have what's called a default port. So FTP, for example, it's file transfer protocol. It lets you transfer files, right? Like you'll host them on a server, your client will connect up, you can download files and put files on the server. And in this case, you would connect whatever server's IP or host name is on port 21 by default to get FTP. There's Secure Shell, which is port 22 by default. There's Telnet, which is like SSH without the secure part. It's very, very rare to see in real life, if ever. There's DNS, where your DNS servers will be on port 53. HTTP is default port 80. HTTPS is 443, and so on, right? And if folks are doing the default ports, it's really easy by just connecting and seeing if it's open, right? We connect to 80. Is it open? Cool. We know that's HTTP. But in practice, this is just a convention, right? I can have HTTP on whatever port. I could serve HTTP on the FTP port. I could serve FTP on the HTTP port. I could pick random ports, right? So this actually presents a surprisingly challenging issue of how do we tell what services are running on a given IP, right? And does anyone have any ideas or like background as to how we would do this? No? There's like one I think fairly simple thing we could do.
/small s big C.
Yes, or any variation of that, right? The real idea is we're going to try everything. We're going to connect to all of the ports, and the tool we'll usually do for that is nmap. So the idea behind what you just said, right, is what if we do that three-way handshake on port 0, 1, 2, 3, 4, all the way up through all the ports, right? Try everything. So that's easy to detect. So in practice, what your tools will do is the two things. They're going to randomize the order, and then they're going to break off the handshake at the SYN steps. And just all you need to actually tell that it's open. And then it'll get past some firewalls actually by doing that. Because you can see, right, there's a difference between what happens when it's open and when it's closed. We just use that difference to tell immediately what ports are open by just connecting to every port in a random order. So yeah, this technique is called port scanning. This is like the most important active recon technique. This is something you'll be doing all the time. And it tells us what ports are open for a given IP address. Oh, hold on. Even though I shared my screen, it wasn't sharing. Let me reshare that. Hopefully that's fixed. If not, let me know in chat. Okay. So basically what we'll do is when we have a set of IPs that are in scope, we're going to go scan all of them, and we're going to see which ports are open. And then from there, we can go see what protocol are each of these ports talking, right? And then we can get a little more specific and say, hey, what service is this offering? And then finally, we could cross-reference that with a big database of known vulnerabilities for any given service, right? And that's a kind of a common practice. So you'll go run through and you'll be like, hey, we have something on port 80. It's a web server. It's Apache 2 point whatever. And maybe there's a vulnerability for that version. Maybe there isn't. You can go check your database to go see that. Now, I want to put a disclaimer here. In a real engagement, you do not just go straight to scanning everyone's like infrastructure. There's usually a lengthy passive recon phase before this, which is like, hey, we're going to go on and look through the purchase history and see what servers do they own, so we know what to scan, right? We're going to go see like what employees are there and what is their tech stack, so we know what services to expect. You know, if you're like an advanced bad guy, this is where you would go get your covert infrastructure ready to go connect into it. None of that really matters right now because we're in like a lab environment, but it's just a standard process thing to be aware of. That when you're engaging a real target, you don't go straight to nmap. You'll usually spend time scoping that out. Okay, so now we can actually get into like the usage of nmap. So nmap is the thing that does what I just talked about theoretically. It will go scan all of the ports on your target. There's a couple like tips and tricks because I've run nmap at least 1,000 times, probably more than that. Like the -pn, for example. That's whether you ping your target. If you don't do it, you ping your target by default, and they're like, oh, it doesn't respond, then it must not be up. So Windows, for like your default Windows computers, right? They actually got, they knew about this in like the 2000s, and we're like, oh, we're just not going to respond to pings. So if you want to scan anything Windows that's not a server, you're going to need that flag. It does make your scan a little bit slower. And then -A is really nice because it'll automatically run scripts that make sense, right? So if we hit port 80 and we see it's talking HTTP, then go run the HTTP scripts. I believe it will also run OS fingerprinting, which will tell you based on how it handles the packets. Do we think this is Windows or Linux or some Apple family device? SV does version checking. So it'll give you more information on, if you're talking this thing on some port, what is this product, right? Like, hey, sure, we know it's port 21 FTP, but we could do SV to say, hey, this is very secure FTP version whatever. That's super important for finding vulnerabilities. VV enables very verbose output. You just see more of what's happening, which is nice because it's kind of like your progress. -P scans every single port. By default, nmap will be scanning the top 1,000 statistically most common ports. This is fine for speed, but it's not very thorough, right? And as an attacker, we want to be thorough. We want to have all of the information we can get, right? Which is why we're going to scan all of the ports because you can have weird stuff running at high ports, Like a common example would be like if you have some like garbage Bluetooth mouse application, right? And you can like send frames to it or like a keyboard that's doing it networked for some reason, right? Well, that'll be listening like a random high port. And you want to be aware of that because that's rare, like that's a really easy way in, right? Or I've seen like random like video games open these things up, right? So you want to be aware of absolutely everything that's going on your targets. So these are like how I usually run nmap. You can run it a bunch of different ways. So a very good manual page online for what everything does. And then most importantly, save the results to a file. That way you don't need to ever like rescan to double check. You just scan it once because these can take like up to 10 minutes to run. There are some weird edge cases, right? So like that goes over all of the TCP services. there are some really important UDP services for attackers. And if you want to get into that, we don't have that in our lab. You'll have to go through some external training, right? But like simple network management protocol, that's a UDP service. It goes on port 161. And that can expose like every process running on a machine with all of its arguments and a bunch of other things, right? Like really interesting information for an attacker, even if it doesn't necessarily present a direct way in. Right? So if you want to do that, you'll need to do a UDP scan. That'll take a lot longer. So you only want to scan 100 ports, right? Because no one's scanning all of the ports on UDP. It would just not ever happen in time. The last thing is we're using a proxy. I'm going to kind of go through this quickly because we're going to get back to this in a couple of weeks. You actually, if you're using a SOX proxy or any kind of TCP proxy, you can't do the SS scan, which is what we were doing before. We break off at that SYN layer of the handshake. We need to do the full TCP handshake through. That's just a quirk of how the SOX proxies work. And the last thing is the workflow tip, right? When I'm going through and I'm scanning hosts, I'll make a directory for every target. So I'll be like, hey, we have this IP. I'm going to go into it. I'm going to go run this command, save this output to a text file. As I'm going through and researching, right? What are these services? What are these products? Are they vulnerable? I'll have a place to go put that information. Because when you're like a /24 network, right? You could have like 3 dozen hosts or even more than that. You want to make sure you're keeping track of the information that you're getting as you're going through this. There is an alternative I wanted to mention. I wouldn't use this for like professional pen testing, but like hack the box, it's great. RustScan is nmap rewritten in Rust. Nmap can take you about 10 minutes to fully scan. RustScan will do it in 3 seconds. RustScan, the way it works, it does that full TCP handshake. It's not stealthy at all. It doesn't bypass firewalls. It is basically nothing extensible. It is like the fastest port scanner. And if you're just like blazing through CTF challenges or a lab or whatever, and you just want it to work, this is great. I think this is like Henry's port scanner of choice for most of the training. So. For RustScan? Yeah. In theory, RustScan lets you directly pipe it to nmap. In practice, it's a little wonky, but RustScan will immediately get you the open ports, and then you can have it subsequently re-trigger an nmap scan with all the flags. So RustScan will be like, boom, it's got like 22 and 21 and 80, right? And then it'll say, hey, launch nmap only interacting with ports 21, 22, and 80. And that's kind of how it works in practice. So it'll basically just alleviate the initial scan of all the ports and then immediately pipe it through. That way, it should be able to get everything in theory. Practice is not so nice, but in theory, it works great. Okay, so that was like a lightning fast introduction to port scanning, right? So what you're doing on pretty much every host you interact with, you're doing some kind of port scan. And nmap will get you some information on the target services, right? Like the version. But there's a lot of stuff that you're not going to get just from the version. So if you have a service that lets you transfer files, for example, we need to go in and look and see what files can we get. Because sometimes it's like nothing, right? It's like some garbage PDF junk, we don't care. Other times you could have like, login credentials left on there, right? This is something you'll see actually a lot if you have like developer environments where folks are like sloppy and they're like, oh, we're done, we're going to push it, we're exposed to the internet, whatever, and they don't fully clean this out. You can actually see stuff like that in real life. So the big one for stuff like this is SMB. SMB has a lot going on, right? I can't go into every single feature of SMB because this is like the main thing that you talk to Windows computers with. However, there are some important things. SMB by default will expose the C drive of your machine, right? On Windows, so you have your C, you have all your files in it. If you have a valid administrator password, you can log in, view, and replace files in the entirety of the C drive. And you could start services, right? And services means something a little bit different than what I would talk about services here. Services are like running a program with the highest privilege level in the background. So to put this together, you have a valid administrator login. You could log into SMB and then go run a program you upload to it as system. That's like an old trick that still works. Right? This is why it's important to think about the sort of primitives that these individual services will get you. Right? And there are a bunch of tools for this. SMB client is how you get on there and then go like manipulate those files, like log in, upload and download and list things and move around the file system. And then you can use the tool called psexec, or there's many variations of it, to go do that trick where you use a valid login to go own the machine. Interestingly, right, there's an old vulnerability for like if you have old Windows 7, which won't happen much in IT networks, but in like old operational technology networks where nothing ever gets patched, that's pretty common. Then there are some vulnerabilities that'll let you just get in and run things as a system with no credentials at all, and just completely compromise that box. So this is why vulnerability scanning is important, right? Because if we have like an old Windows 7 box that hasn't been patched in years, you could just immediately get it. It's like totally trivial. If there's a Metasploit module for this, if you guys aren't familiar, Metasploit like packages up exploits instead of having to really understand them. You can just punch stuff in and hit run, and it'll do it all for you. And you can literally just set the IP to your target and hit run and fully take it over. Like that's how easy it is to go do this. Yeah.
Let's make a connection with trying to keep up and understanding this, because there's a lot to unpack. We'll talk more about this like so much later in the coming weeks at the Red Team meetings. But like when we do like active reconnaissance, the whole point is to try to find open ports and services, because what you're trying to ultimately get to see is softwares, versions, right, operating systems, information about a system, right? Then you associate that in time, we'll see that later, with known exploits or known vulnerabilities of that software or system. So that's what he's telling you about are the various tools that you get to obtain each of that like specific unique information. But like right now, I won't talk about anything later than that. It's just nmap, and then he'll expand on that too.
Yeah, and I was gonna. This will become much clearer once I give like the live demo, because I'll actually walk you guys through like every single step of this. Right, but yeah, the idea is you'd run nmap first and see, oh, we have this port open. Then nmap would say it's probably SMB, and then you can grab a tool like SMB client and see, oh, can I log in? Does it allow anonymous logins? Right. And this is how you would gather more information. And there's a cool site, which I'll show off later, called Hacktricks, where they have a list of like tools you can go run for a given service. So you can just go Google like, oh, I haven't seen this before. Like, what's SNMP? And you go to SNMP Hacktricks, and they'll tell you all the tools you can go run to get as much information out of it as possible. I was just giving this as an example of like, this is why this matters, right? There are multiple ways to completely compromise the confidentiality of all of the information on a system if you just have this information in the background, right? To be able to do that. So I'm gonna like blitz through these. You don't have to memorize these or anything. You can easily like Google this and figure it out on your own, just to give you some background, right? Each of these services are gonna expose functionality. And if they're vulnerable, that's great, because we can just get in. And other times we can put pieces of functionality together that are not supposed to go together to do really unexpected and cool things. So here's an example. It's kind of contrived, but you'll see it sometimes in real life. Which is that if you have a web server, right, and it's running like PHP files. So, you know, you have a file and then you visit that on the web server and it serves it and executes it. Cool. What if we have a file transfer protocol that's anonymous login and lives in the same directory? Well, now we can put up a PHP file on that, right? So we have one primitive via FTP that lets us get and put files. And then we have another primitive through the web server that lets us run files. And we can put those two together to go put a file that's malicious and then run it, right? Now that might not be one known vulnerability, but by going and reconning and saying, hey, we have a PHP server, we have an FTP server, we can put the pieces together and use that to go take a machine over, right? Which is why it's important to go through all of these and see. What's up, Bryce?
How do you run the file after you upload it?
Go visit it via the website. Yeah, so maybe I should have made that clear, but the server will run it every time you get a request to that URL and it exists, right? So what you would do is you could put, and I'll show this off later, it's called a web shell, which is, it's like a little malicious web page, like let's say a .php file, and then you put like a little command in the URL and they'll go run that as like a shell. So we put that on the server via our FTP, right? And then we visit it. And now by visiting it, we can run whatever commands we want and we own that server. But again, these are just like one-off examples. In practice, it's gonna be up to you guys to go through and learn just a little bit about each of these services and kind of think creatively of how can I put them together. It'll be like a different thing every time, you know? Because a lot of these services are modeled with like different assumptions. Like for example, Redis as a database, it's totally fine, but Redis is not supposed to be exposed to your network. It's supposed to run on like localhost, last I checked. So like even the creator of it admitted, you can just get into someone running this, like this service, right? Because that's not in this threat model. They don't threat model around that being exposed to everyone. And this thing is scan will pick up and be like, hey, you know, we see this, you can get in and go take the server over that way. But like I said, you won't know every service. I definitely don't know every service. But if you get the flow of understanding unfamiliar services quickly and like quickly researching these things, right, with something like hack tricks or reading through documentation or anything else like that, you can get some good preliminary workflow for, hey, I have this unfamiliar thing. How can I poke and prod at it and see what unexpected stuff I can kind of get out? So when you don't know something, right, Google it. Seriously, because whenever you see a service and you're like, how do I attack it? It is almost guaranteed somebody else has seen that service and tried to attack it. And reading through stuff like that is super helpful, and it's a super fast way of gaining familiarity, right, with working with new things. So I know it's all like vague and it's a lot. This will become, I think, a lot easier to grasp once you guys are hands-on keyboard running the tools. Because in reality, you could do a lot of these things I talked about as like multiple, different theoretical things, like 1 or 2 commands. It goes way faster in practice and in theory. So, like I said, that's like a lightning quick overview of networking and services and different service primitives. Now I want to go over some of the most common patterns that we see in real-world breaches, right, of bad guys getting access to these services. And these are like pretty, like really big umbrella categories, right? So the first one is just exploitation. So, right, as we went over with SIGPwny General, there's gonna be a lot of like core sorts of vulnerabilities that certain software will have, right? And that's why we constantly try to keep things updated in like a real environment, so we're staying ahead of the curve of that. But if folks don't have good patch hygiene, like, we were running around SIGPwny and found at one point we had servers that weren't updated in 7 years, right? If you have stuff like that, well then, there might be one of these flaws that's still very easy to go exploit. And you can go find an exploit code online and then make it very, very easy for you. Because there's something called exploitdb, right? Exploit database. And there's a command line tool called searchsploit that looks through it on the command line really quickly. And it'll be like, oh, cool, we're going to run through like every single thing we can keyword tag with the software and tell you if there's a way to get into it that someone's already found. And it'll just give you like a script, you can just go run. So an example is, right, for the thing on the cyber range, there's a web app there where if you look that up, an exploit database, there's a shell script you can just grab and go to go gain access to it, right? And sometimes it'll be a little broken and like some minor tweaking, like, hey, they missed like some random bracket or the IP needs to like manually change the source code. But usually it's like really easy. You just look it up, grab the script, read through it, right, and make sure it actually does what it says it does, and then you can just run it, right? And this is like probably the simplest way to get into something, right? Is you just scan all the ports and the services, and then you cross-reference that with this database, and are like, okay, it's vulnerable. I have a script here. I can just run this script and access the server, right, or whatever. So this is like a very common sort of class of attack. Another one that's a little bit more pernicious and equally dangerous, but also more common, is misconfigurations, right? If you have services that are set up with really silly permissions, right, then that can also allow for a complete compromise. It's a little bit trickier though, because it's not going to show up to an attacker or a defender as some big, obvious, like highlighted thing of, oh, I can go run this and get a shell or take it over, right? This is they have to kind of get familiar with the service and understand, hey, what does normal look like? So it's just an abnormal, you can go take it over. So there's way too many possible misconfigurations to even cover. A common one would be like Active Directory. Active Directory is like complicated. I don't want to get too deep into it. But let's say we have a misconfiguration that allows me to go log in to a box as anyone, right? Anyone at all. It's actually very common. It's called unconstrained delegation, right? And it used to be recommended in like the early 2000s as a method of like managing things a little bit like non-standard, right? Like servers need to connect in a weird way. Just be a little extra permissive, right? What's the worst that could happen? Well, the worst that could happen is I could log in as a domain administrator to a box I control, and then, oh, well, I'm domain admin, I own your entire network, right? And that's like one hop away, you just log in and you're done. So that's like probably the most egregious misconfiguration that jumps to mind. But the world is your oyster for this. You're going to have a lot of different possibilities, and the only way to really get awareness of it is just to know over time, through practice, through instinct, what does normal look like, right? And then lastly, and this is a fun one, password attacks, right? So whether you can pull this off depends on your environment, because some things will have password lockouts. Where they're like, okay, this account gets 5 tries, and if you fail 5 times in a row, no more logging in for a half hour or something like that, right? So you want to make sure before you do this that your target does not have lockouts. A common target that doesn't have lockouts would be WordPress, right? WordPress lets you authenticate as many times as you want, as many people as you want. So, if you have like 10 servers going after this, you get 100,000 a second, which is like, that's a lot of logins, What's up?
If like the target is running an unknown service and you can't find the service online, how do you know if there are lockouts?
That's a great question. The short answer is you really don't, and you want to tread carefully, right? I would recommend against brute forcing things, especially if it's like a real target that you're getting like paid to engage you aren't deeply familiar with, right? You could try to go analyze the behavior with like something like Burp Suite or other web tools and see, okay, if I try 5 logins, right, do I get slowed down? Or are they like sleeping between each login, right? So it like waits a second to return to me. But it's a very good question, and there's no easy answer. Like if it's a brand new piece of software, you're just not going to know from the outside a lot of the time. So this is the reason why a lot of advanced attackers use something called a password spray instead, which is where you pick a weak password and then log into every single account. Which I wasn't going to go over that now. I was going to cover that more in Active Directory. But when real bad guys are going after unknown services, they do have to do that all the time. The most common like pattern we'll see is they'll pick a password that was either in data breach or is like really obvious and guessable, right? And they'll try it one password against every single account. And trying many passwords against one account is a password brute force. Trying one password against many accounts is a password spray. And password spraying is more common. Both of these are very easily detected by defenders, right? Any defender is going to be able to immediately tell, hey, you're logging 100,000 times to my web server, or you're logging into every single account within like a second of each other. Like they're going to be immediately detectable. They're still worth knowing because anything that gets you access is important to know about. And you'll have a lot of times where you'll put these together, right? Where you'll have an exploit, but it requires a valid login. And then we can put these together by brute forcing a valid login and then using that to gain access through an exploit. Like let's say you have like an admin panel, lock panel login. So before I continue to like just how to get a shell on a target computer and control it, I know I went over a lot of stuff really fast. Does anyone have any like immediate burning questions? Are folks like totally lost? Anything like that? Okay, cool. Then I'm going to continue briefly to how we actually control computers once we have exploit that works. And then I'll go into a live demo. And then Henry, I didn't see your message, but are folks able to log into their boxes and access the range now?
Well, I'll just let you finish the
Okay.
content.
Okay, cool. Yeah. So, right, a lot of times when you're looking to test your vulnerabilities, right, because real hackers are a little bit different. This is good enough for now. You're going to be trying to go get a terminal, right, on the remote computer. And it's not like as easy as just opening up the terminal program on your computer, right, where you can just type into it, whatever. You're going to need to connect to it over a network. And there's a couple different ways to do this, and you'll see this even with more advanced malware, right? The first thing is called a bind shell, where your shell that you'll put on the target, right? So this is a situation where we can run anything we want. Let's say we can run any command to exploit the vulnerability or something like that, or we have like a valid administrator login, and we can get in that way. We can run any command. How are we going to control the computer? Well, the like old way of doing this is you have a shell that listens on a network port like a service. So let's say I spawn a shell, and I say we're going to listen on port elite, right? Like something silly. And then as an attacker, I will connect to that shell and use that to control the computer. Now, this is generally uncommon, like for the overwhelming majority of cases in practice. And does anyone have any ideas as to like what's wrong with this picture? There's a couple things. There's like strictly wrong with it. It will work. There's a couple big considerations as security folks you might be able to kind of think about.
Firewall typically allow you to access that specific port.
Yes. Sometimes you can get around this, like the web shell, but firewall is a big constraint. There's 1 or 2 other big things that are kind of top of mind why bind shells aren't great. Do you have one?
It might be really obvious.
Yes, it is really obvious. There's 2 of the 3 big things. It is super obvious, in fact. And there is one last thing that ties right into that. Does anyone have any guesses?
It's hard to get the victim to listen.
That actually depends. I would agree with you in the firewall sense, where a lot of times we won't be allowed to connect. Generally, if you're on a high port, even an unprivileged victim will still listen, and you'll get around the host firewall, but there, again, could be another firewall that stops that. That's a good guess, though. If you're trying to listen on a privileged port, or like a normal one, like 445 that's already running, it will get denied. So it is actually true. The main thing I was going for, though, as security folks, is that anyone can connect to your shell, right? So let's say we have a web server online, right? It's like, big deal, we get into sort of bind shell, something like that. Well, now what if another bad guy was able to figure it out and they can just connect in and get a shell on the target? Well, that's really not good, right? Especially, let's say you're a professional pen tester and you've been paid by a client to go engage their really important production server, and you leave a giant unauthenticated bind shell on their production server that any old bad guy on the internet can connect into, right? So those are a couple of the reasons why you don't see this compared to a reverse shell, right? All of this is technically a bit of an oversimplification because a real attacker will be using what's called command and control, but we'll get into that a bit later. So this is the real common pattern you'll see, where instead of having something that binds on the target and we connect into it, the attacker will bind and our target will connect out to us. And this is called a reverse shell, right? So it's a bind shell, we switch the direction of what's going on. So in this case, the attacker is the server and the victim is the client in this case. This is more secure just because, right, like it's only connecting back to the attacker's IP address. It's more normal because most software clients, like when you're browsing the web, for example, are going to be talking out to things. Things are not talking into them. And it's a little bit harder to detect, right? This is still not hard to detect by any stretch, but it's a little bit harder to detect than a bind shell. And these are the kinds of patterns, right? So when we get a little more advanced, how would you put this together when you have a situation like this, right? It's just like food for thought. Where you have like, hey, we can only talk in on 443, right? And we have this other network, we can only connect in and not out. So, you have to kind of sometimes put these together to get through strict what's called network segmentation. So it's important to know all of these different methods of connecting things up. So to kind of recap and put everything together before I have you guys start doing this, we'll begin with just a quick scan of port scanning of all the in-scope IPs, as in, let's say with IP addresses, we know we need to target. We're going to go do a quick scan of all of them. And then for the handful of them that are up, we're going to go do a full port scan, right? So we're going to do a quick scan, right? We have a couple hosts up. And then for each of those hosts, we're going to scan everything, right? We're going to scan all of the ports. And ideally, we'll do scanning for the operating system. We're going to go check what applications are running, what versions, if we have any known vulnerabilities. And then from there, we're going to go pivot a little further and say, okay, I see you're running this. How can I get all of the information possible out of that given service, right? If it's SMB, we're going to get as much information out of SMB as possible, right? For everything that has exposed before we go into actually attacking. So this will help us start to figure out any kind of like weaknesses or like weird things that stand out about a host. And then after that, that'll be the end of the recon phase, and we can exploit the vulnerability and control the computer via a bind or reverse shell, right? That's like the general workflow, where you start like really, really in the dark, and you're like, okay, what's up? Okay, cool. The things we know that are up and online, what are they running? And then of what they're running, is there any information we can get from that? And then from there, we pivot to being able to actually get into the target. So here's a silly hypothetical network of like common sorts of attack primitives, right? So let's say I'm a bad guy and I'm on this network of 192.168.10.0/24, which means like all of the IPs in that very last digit of like 0 to 255, I think. I don't think you have 0 as an IP, but something like that. Anyway, so we need to go see on this network, we're totally in the dark as to what's on it, what are vulnerable devices we can attack and get into. So we can begin by just doing a small port scan, right? You can do -F to the top 100, or in this case, I chose like 5 to be really quick, and just like a quick like sweep, right? What's up here? And we're gonna first just see, right, what are the computers? So it didn't even tell what they're running, because we're not being thorough about that. We're just saying, how many computers can I talk to? And this like fictional example, there's 4 of them, right? And the other thing is, just in terms of like saving your time, you don't need to scan all of the ports for all of the IPs in one shot. That's like 255 times 65,000. That's a lot of wasted work. We could just do like 5 of them times 255 and save yourself a lot of time. And then from there, right, We now know we have 4 hosts. We're going to go see, by scanning all the ports, checking for the versions, and running scripts, what's up with these, right? Like, what can we get quickly from looking at these targets? So let's say the one on the left, we see it's running SMB version 2, and it's really old Windows 7 box with multiple terminal, right? And let's say this other one is running SMB, and it's newer, it's not vulnerable. They have what's called open shares, where anybody can log in, right, and go view files in the box. So that can be dangerous. Let's say we have another Linux box. They have file transfer protocol on it. You can be able to log in that way, right? If it's like open to everyone, that'd be a misconfiguration. Or let's say we have this web server, which is vulnerable to a known vulnerability. So in practice, real networks are not going to be anywhere near this vulnerable. In fact, 95% of the hosts at any one given point are not going to be directly exploitable, and you're going to need to kind of work through multiple user accounts and kind of pathfind your way through to get to everything. But for like a lab, this is totally fine. So in this case, right, as an attacker workflow, we're just like, hey, we know it's vulnerable. It's vulnerable to this vulnerability. We have this exploit. Let's run it and get a reverse shell, and then we connect back, and now you own that target, right? And that's like a very common sort of scenario: is known vulnerable software. I have an exploit for it. Run it and get a shell. Sometimes we can have valuable information exposed in like maybe somewhere it shouldn't. A lot of times, this is realistically not going to let you immediately log into a target and compromise it. It's much more common for folks to leave secret or confidential, like personal things like PDFs open to the internet and login credentials, but you will still sometimes see it. So this could be another scenario, right, where, oh, well, they left something open in their SMB share, and we can use that to log into the box and own them that way. Not every box will be vulnerable, right? So let's say we have an anonymous login on the Linux server, but like doesn't have anything of value. Well, maybe we're going to need to come back later once we figure out whoever actually owns the SSH key to get into that, and we'll just be like, hey, we can't get into this right now. And the last thing I want to talk about is a web shell, right? I alluded to this before. This is a special sort of like bind shell where you have a little web page written in whatever programming language the website is written in. And you'll go find a way through some kind of vulnerability, right, to put that on the website. And then when you visit it, it'll run. This is like a very special sort of bind shell. We see these in real world attacks all the time, even though they're not super hard to detect generally. Right, you're always going to go through the firewall in this case because you're serving the website, and just access by visiting the site. And there's a big, thing with this called Tool Shell that happened over the summer. If you want to go give it a Google and see what that was about, where all of the SharePoint servers had this sort of known, at the time it was unknown, now it's a known vulnerability that would let you, again, just run a script and immediately deploy a web shell and compromise it this way, right? And that was something people thought was secure because people didn't know that vulnerability was out there until it started getting exploited. So the process for exploiting a known vulnerability versus an unknown vulnerability from an attacker's perspective is the exact same. So something to keep in mind. So I was going to go over next meetings, and I intentionally left about 15 minutes. So assuming our infrastructure is up and good to go, we can actually go like practice this. I can go show you guys what this looks like for real instead of just going up and talking about it. Are we good to go on that front, Henry?
Yeah.
Okay. And then how are folks going to be VPNing in?
I put a file server in there. I can drop the file in Discord.
Okay. Let me go log in.
I will put it in general, and you can pin it.
Okay. Here, let me go into my testing box. Okay. So at this point, for those of you guys who want to go through and do this practice, and you don't have a web login, just go put in Discord in the purple general channel, like I need a login, and we will go get you guys one as quickly as possible, right? So you can go participate and go do this. So you guys should be able to log into it. It's now ponyoS.purple.sigpwny.com on the normal HTTPS port, and you can go log into that and start hopping into the cyber range here. Okay, cool. And then whoever Mystery Blue is on Discord, I actually got you your login earlier today, so you're good to go. And I will try to get to the other logins like right after this demo. So
I can do it.
Henry, what do you want me to go real quickly? wget, what do we wget to get the VPN file?
I set up the DNS, so it's literally just called file.server/attacker VPN something something. It's a web server. You can just like use your web browser to go HTTP file.server.
Okay.
Okay.
I think it's this. The attacker VPN. Okay, cool. So yeah, anyone who is logged in, so I see folks are logged in through PonyOS boxes here. You can just wget file.server/attacker VPN, then hopefully it'll actually go run. Since I was just testing this before. Awesome. Okay, so this will let us VPN into the actual like range, which has a big domain full of vulnerable devices. So this one's kind of blind, right? It's like for Pony CTF, you know exactly what you're getting into. You guys don't know what's over here. So I'll give you like a little like silly story brief before I show off by going through visiting this. The story for the cyber range we have is that you are bad guys looking to execute a supply chain attack against government contractors, but you can't directly connect in. So you're going to go attack Amazon Web Services, hosting the big secret cloud, and you're going to go deliver an exploit to your target network. And you're going to start by looking into our silly little site, Amazing Fresh, and seeing if you can get into that and work your way through all of Amazing into Amazing Web Services, and then finally go into the super secret contractor. There will be many Pony CTF flags. We did not add them tonight, but they're like really easy to add. They'll be up definitely by next meeting for you guys to go work your way through this network. Kind of like a really big set of hack the box boxes.
Sorry, for anyone that needs to log in, can I have a show of hands? Okay. Well, didn't I give you anything?
Okay.
Oh, no.
So in this case, one quick thing, and I can go pin this to the Discord, is that your in-scope IPs is, yeah.
PSA, if you have an account but cannot log in, make sure you change the authentication method from Linux PAM to Proxmox VE. Yeah, you can keep going.
Okay, yeah. Okay. So is my font big enough for folks to read, by the way? Is that okay? So this is, if you guys want to start running your nmap scans, I'll show you exactly what to go run. This is your in-scope IP range to try to get in. So we can do sudo, because we have to run with root to be able to manipulate the packets, nmap, and then let's just do a quick like scan, right? Let's do fast, 192.168. What's up? Okay.
Is that easier for you guys? Is it fine to run this
Just make sure you're VPN'd in, right? Otherwise, you'll be
Anyone
scared.
that needs me to debug for them, anyone already has an account? Okay. PSA, the file.server thing is only for our Proxmox instance. If you have your own setup, please download the VPN files that I posted in Discord and drag them in your VM machines. Need help with the VPN file? Just raise your hand.
Yeah.
Yeah, no, I have like there are purple team helpers who should be able to go out and help anyone who needs access.
Oh, okay. Just copy the files. Oh, you can access it. Okay, I'll come back to it. I don't do it internally. I would not do it in.
Okay.
So,
All right. So I was gonna say, has anyone else been able to like start scanning things? hopefully. So, yeah. So you can do this however you guys want. You could also add -- open to make it a little bit less, like verbose. But this is your target set of IPs. Please only scan that range. And then this is the nmap command you can go run to start seeing what services are running. I think over there we've got 2 people. Yeah.
What's the new? Is it like IP matter?
That's just IP space A, right? Sigit on your left. Yeah.
Now you can go after that. If you want to attack any right, yes,
Otherwise, you could because we're using like random local IP ranges. If you don't VPN in, you will be scanning whatever is on like your local network. Which in this case, with your home network, it's like I don't really care. If you're on Illinois net, don't do that.
Anybody else?
Should be able to get whatever password you have on the sheet. So if you have that, so just remember to click on the actual VM for next time that it's started. Yes, put in your password, you should be there, go to your command line, and then type that in without scanning.
Okay. Oh, wait. That's different because
All right. Before I keep going with this, who still needs a weblog? And I can go do that kind of in parallel. You need one? All right. So I'm just going to go down the line and start DMing folks with what I need. Once you respond to that, I'll give you a weblog in. Yeah. What's up? The VPN, so we have if you think about how this is set up, right? We have all the Pwny OS boxes on one rack, and then we have all the simulated info on the other rack. And all of the network lives inside this rack. And the VPN is what's going to get them on that simulated local network. Otherwise, when you scan, you're scanning your real local network. We don't want that. So when you run the VPN, that's what's going to be getting you to scan that IP range.
Nice red walker shirt, Rich.
Okay. I think I went over and DM'd everyone except someone had their thing set to friends only. And then if you respond to that, I could start provisioning web logins like while I go through this.
I think the network is cut. They can't reach any of Google's DNS servers or down.
Okay. Well, Henry was messing with it before. I can still go through with this then, but we had it working as of like 3 hours ago. All right. Well, in that case, I'll keep going. So for this, right, we want to get a little bit more information as to what these products are. We can see this looks like it's a web server, since we have secure shell and HTTP, right? Now, realistically, probably HTTPS, but good enough. And then this looks like it might be some kind of mail server, because we have SMTP, POP3, and IMAP. These are all used for sending emails. There's some weird stuff in the filtered range and SSH open. So let's go poke around at the web server first. So we can do sudo nmap sv to send the version, aggressive, ports. Actually, we don't even need that because we already know. Here, 2168.10.10. Oh, hold on. Yeah, I was going to say my Discord notifications are showing up on the big screen. So, yeah, hopefully I can get those out of the way. Go. We could do script vuln. This will give you a lot of noise, but it's at least decent. Okay. And this will take a moment because we're scanning every single port and doing a bunch of script stuff. So while that's running, I'll go get folks more web logins. And then has anyone here been able to run a scan successfully? Okay. Why is that so slow? I wonder if everyone scanning it is taking too much time. In that case, let's just make it a little faster. Okay. All right. It's almost done. Cool. Yeah, that was Michael's thing. It doesn't really matter. I just want you guys to be able to see the screen. But all we're doing right now is waiting for nmap. The fun stuff hasn't really started yet. Okay, well, now the fun stuff will start. So you can see this lists a lot of things. You can always feel free to go through and double check it, but I know from doing it, these tend to create a lot of noise. Like you are almost never going to have a real remotable exploit against SSH, right? That's not going to happen. But we are going to have some interesting stuff here. So we see this is an Nginx server. It's scanning for CSRF, nothing really there. Then it's going to say, so we know for a fact that this will be serving web content. So we can go open up our browser and go take a look at that. Then let me have it run one more thing. We can have it run scripts designed for HTTP using the -- script vuln. So let me do script HTTP. Just do it on port 80 and see if that'll pick up anything else. We'll have a whole meeting on enumerating web servers, but this is a good start. Seriously, it should be HTTP -- usually. Okay. Well, we'll go through this regardless. It should be 192.168.10.10. I don't know why that is not loading up since we can connect to it right here. Yeah, okay. So it's trying to redirect us. There it is. So we got that redirect. Oh man, the face looks so much dumber in the intended font. But that's okay, right? So we can see we have some kind of website going on over here. Looks like, you know, I can guarantee you there's nothing of value in the actual store portion of this. But if I get rid of the script vuln and rerun it, it should be able to actually pick up on something interesting here. Let's see if nmap picks up on this. While I'm waiting, I'll keep adding users. Box. All right, so we can see it's redirecting. I don't know why. It should be a robots.txt scan. Okay. So if we go to robots.txt here, which is the scan will pick up, we can see robots is a little file that prevents web crawlers from hitting certain pages. Sometimes you can use this as like a sitemap. We'll go over next week how to actually brute force all of the URLs in a website. But in this case, right, we can just go poke around. What is this? Oh, what's up? So what should have happened when I ran nmap literally an hour ago is the nmap scan will pick it up. I think everyone's scanning it. It didn't pick it up. But you'll see there's modules under HTTP. One of them is called HTTP-Lino, and it'll pick up robots.txt. But again, I think we have a bunch of people nmapping it all at once. It didn't come up. So, but it happened every time I scanned it from Cali, like before you guys were on the network. So I'm assuming it's just overloaded. So we can go over here. And we see we have some kind of like login panel. So the first thing I would do here before messing with this is I don't know what Tiny File Manager is. So I can go look this up and see like what is Tiny File Manager, PHP, right? And we can see there's like a GitHub repo right here. And then the next thing I'll do is I'll look up, oh look, Tiny File Manager Authenticated RCE. So one of these, yeah, right? So we probably know, hey, you know, there's going to be some kind of authenticated RCE exploit. Let's just look it up. Tiny File Manager exploit DB. Let's see what we have here. And then, right, if we go and look through this exploit as a couple dependencies, right, it requires to be run in Bash from Linux. It needs JQ, which parses JSON. We could see, yeah, this is an authenticated RCE because it requires the admin username and password. And we can look through this exploit here and say, all right, we have some form parameters, form user, form password, right, that we're going to be using to go log in. It looks like we can go test this ourselves. And it looks like here, right, we're going to be doing something strange going on with files. So this probably, we could say, yep, file upload. So this is going to be one of those cases where it looks like this vulnerability lets us do something to upload files, and then we can run them by visiting them. So a cool thing about exploit-DB, and you should have search exploit on this box, I would hope. Let me see. Search exploit. Yeah, search exploit. We could do -m if we have this index and get this number. And then that'll let us grab the exploit locally. 50828. 50828. Okay. And now we have this 50828.shell. And we can go see, okay, well, this needs us to actually like go log in, and we can go see, do we have default credentials? Your default credentials. Okay. Yep, so the default password it looks like for this is admin at 123 and user 12345. So let's give that a shot. admin at 123. And we can see, this doesn't work, right? So we want our authenticated RCE, but we can't authenticate. And what you would do at this point is you would probably go look through the app source code. I will save you guys that time because you have to go kind of deep into it. But in a nutshell, this does not rate limit you. It does not rate limit your logins. It does not block logins. We can log in as many times as we want, right? So what we can do is we know there's that user account. We know there's that admin account. So we can try to log in with them, like through a bunch of logins and see if we can make our way in.
Do you want to just zoom in full screen this?
Yeah, I was just doing that. Yeah, hopefully this should, is this visible to you guys? I have it pretty blown up, but. All right. So if you guys remember for like the SIGPwny web meetings, right? We can go to network to view our network requests. So let's see what's happening. Let's do admin. Let's just make some up. So it's like test123 for our password and send it. And then we can go and see we post over here. And if we have these parameters, form_user, admin, form_password, right, test123. Let's see what we get in the response, right? Let's just look at the raw HTML here, but we should know, right, that did not work. And there's a tool you can use this kind of thing. In fact, for just about any kind of login for password enforcement called Hydra. And I'm hoping this won't explode the website if we all run it at once, because it's a fairly intensive tool, because you're going to be logging in basically as quickly as possible. But what we can do is we can actually grab that form user and form password and then use it to try to brute force into the site.
That was recorded, right?
Yes, it should be. So we should have Hydra. And then I will save you guys the pain of getting this command syntax up because there's a lot going on, right, with Hydra. But main thing is we need our service, which would be HTTP post form. We need our target, which is going to be that amazing fresh site. And then for the optional parameters, we need everything we would need to actually log in, right? So we know from just that quick Google search before, we want to log in as an admin. And we know just, that the default username is going to be admin. So we could try admin. If that doesn't work, we could try user. So we can do Hydra. We do L for the username, admin, P, and then there's a very big, very famous word list in here called rocku.txt. Rocku contains a lot of really weak passwords that was in a big data breach, I think over 10 years ago. And you can permute these and still get to pretty common weak passwords today. Now, as a rule of thumb, just so you're not like burning through a bunch of network or GPU stuff, if something is brute forceable on our cyber range, it will be in Rocku, right? In practice, you need something a little more complicated, but that's to prevent you guys from like burning a bunch of time and like GPU hours on this. So we can do user, share, sec lists, and this will be on every PwnyOS box. Passwords, should be leaked databases, rocku.txt, and then will be an HTTP post form. And then we go to our target. So we have that like protocol up there, and then we have targets. This fresh site dot amazing.pwny, and then tiny file manager. And then we just put in the parameters from before. Form user equals user, and form password. Oh, this would be USR. Equals pass, and then we do our failure string, right? So let's see. So we look through this form, right? Through our request, what are we sending? User is admin, password is whatever we want, and then in our response, we need to pick a phrase that differentiates a failure from a success. So we're going to say, hey, when this phrase is missing, we know we've logged in, and we can go like invalid username or invalid, right, or failed. Any one of these strings will do to differentiate it. So let's go invalid. Okay, and hopefully this will work. I may need to apt install. You need apt install cyclist. Okay. Hopefully this doesn't take forever.
Yeah, because you don't have the Kali IP thing.
Did you get rid of my my apt? Okay.
No, but you literally put sec listing opt.
Ah, right. Thank you, Henry.
Brain not brain.
Yeah, I know, dude. It's late.
Wait, it's not there? I mean, it's somewhere. Okay.
Are you sure about that?
Surely we put it somewhere. There's no.
It was on the template machine I gave you to clone, but in that case, I can cheat and hop on the Kali box, but I'd rather not. So
No, well, can you just locate rocky.txt or like something like that?
yeah. 'Cause no, you didn't. Remember, you didn't put this on because of the what's called distribution. So we can just go grab it from the Kali box. I'll go cheat and show this off instead from the other subnet. Yeah, remember this was your judgment call. Not blaming it on you, but that's why, because you wanted to keep the file size down. We were sharing it, so we can hop on the Kali testing and run it here instead.
Wait, I'm really confused. I don't remember doing that.
Yeah. All right, we'll hop on this one.
No, if things your.
All right. What's up?
I had this question during your lecture. You sort of mentioned that a map is stealthy. How does stealthy translate into like actual computer science?
So the main thing is it's running the SYN scan compared to a full TCP connect. So that's the main difference. What's up? Hydra is only complex for the web form mode. It's not that bad in practice when you're taking your time. The main issue is I'm just like burning through it really quickly up here. I'm a little bit surprised that rocky.txt isn't here. Let me see if I can go grab that, but okay. Yeah, this should be recorded, and if not, I can walk everyone through this because the move to ACM infra knocked a lot of stuff out kind of unexpectedly because this was all set up as of 2 weeks ago. But
Ronan,
what's
I
up?
don't think you got a password from
Okay. Yeah, sorry, it's because I got.
Just pause the demo and we'll do it Thursday or something.
Sure. Yeah, we can kick it back. I'll get you your login. I add you as a user. I just didn't finish cloning the box.
Will
Because many
the
people have left.
Yeah.
will the VPN file continue to be valid, or you?
Yeah, the VPN will still be open. So.
As of half an hour ago, I think everything is set.
Right. Works as long as you use VPN. Okay. Well, we can pick this up next.